All right. This is when you really need to pay attention for science, okay? On the board, I have written down a science review, okay? Those that are in class, they've been in here writing as I put things up here. Basically, there were 5 lessons in this chapter. This is chapter 1 on properties of matter. In this lesson, I'm going to go over everything that you need to know for the test. First of all, lesson 1. Lesson 1 was what makes up matter. And in that chapter, in that lesson that we read about atoms and how the atoms are on the periodic table, and you know that the atoms are they make up the elements. The atom is the smallest part that makes up the element. Then we also had a compound. Compound is when you have 2 or more of them together. So in here I talked about sodium chloride, sodium and chloride. When they're together, 2 of them together, they are a compound. Just like when you put 2 words together, like foot and ball, that's a compound word, okay? This is a compound, okay? Where you're putting things together. NaCl, does anybody remember what that was? Sodium chloride? I put some on my omelet this morning. Salt, okay? H2O is another one. Water, okay? These are compounds, okay? And when if you take water and you break it all the way down to the smallest part that has 1 hydrogen, 2 hydrogen, and 1 oxygen with it, that is a molecule of water. The smallest one that has just the parts of it. The smallest part of an element is an atom. Okay? There is a theory out there that's called the atomic theory also. And the atomic theory is that everything that you see, touch, feel, is made up of atoms. Okay? And all of these atoms that make up everything, that is known as the atomic theory. Okay? It's just a theory, which is an educated, good guess that everything is made up of atoms. Okay? Can I ask what you got on there? Is it a game? I don't want to see it out. Lesson 2. This is how can matter be described. Okay? Graham has on a blue shirt. Christian has on a white shirt. Okay? Color is one. Different things are going to have different colors to them. If you go to the carpet store, I hate to tell you, there's all sorts of colors of carpets. There's all different colors of sheets. There's all different colors of cars, okay? Color is one way to describe it. Mass, how much mass does it take up? It's another way. When they showed mass, they showed where they put it onto what to describe it? A scale, which they called a balance, okay? That balance is how you would measure the mass. Hint, hint, hint. Volume is another way of describing matter. Okay, how much volume does it take up? If we took, they had in one of the videos, they took a little toy car and they filled a glass with water and marked where the water went to. They put the toy car in and it displaced, it took up more water in there. From where the water level was before to where the water level was after, that told how much volume that toy car took up. Temperature. Some things are freezing cold, some things are scorching hot, and that's one way to describe it. It can also be a way to find out what the melting point is of something. Because aluminum is gonna melt at a high temperature, but you're gonna have steel melting at an even higher temperature. They both, if you look at them, they both may be silver in color, okay? But their mass, the aluminum's gonna be lighter than what the steel is, which is one way to describe against them. The other one is the temperature in where they melt at. Another one with the steel and the aluminum, usually your aluminum cans are very smooth, and anything with steel usually is a little bit rougher, okay? But the texture, and we talked about texture in here also. Then we moved on to solids, liquids, and gases. Solids. You need to remember that solids have a definite shape and a definite volume. This is a solid. The iPad has a definite shape, a definite volume, okay? Liquids, they don't have a shape. If you pour the water out, okay, right now the water is taking the shape of this container, okay? But if I pour it out onto Kane's desk right over all of that work that he's doing, it's then gonna take the shape of his desk, okay? So it has no definite shape. It takes up the shape of whatever it's in, okay? But it does have a definite volume, okay? Gases have no definite shape, no definite volume. They're gonna take the shape of whatever they're in. It takes the shape of our lungs when it's in our lungs. It takes the shape of a balloon when you blow up the balloon, depending on what the balloon looks like, okay? If the balloon is a big round one, it's gonna take that shape. If it's one of those long ones that the clowns, they sit and make the different, a hat or a sword or, you know, things like that with it, those are the long balloons. It's gonna take the shape of that long balloon rather than the round balloon. If it had a definite shape, when it went into the balloon, it would still keep that shape. But this doesn't. And it doesn't have a definite volume, okay? Now, with solids, liquids, and gases, a solid has molecules that are right next to each other. All the molecules are next to each other. They are vibrating, okay? They are vibrating. So your desk, even though it's not moving anywhere, this desktop isn't doing anything, the molecules that are in there, they are still vibrating, okay? Now, in a liquid, they're moving a little bit more, okay? And in a gas, they're floating all over the place. Now, one thing that is going to make them move is temperature, is heat. When you add heat to something, it's going to make it expand, it's gonna make it move, okay? That's how you can make aluminum from a solid into a liquid. That's how we make an ice into a liquid, is you add heat to it, okay? If you keep adding heat to that liquid, it then becomes a gas, okay? Now, let's go the opposite way. If you take heat from the air, cool things down, it's gonna turn that air, it's gonna take all of the moisture out of it and have it drop as a liquid, okay? Somebody in here had you might have one if you have ice in yours, because I can tell yours isn't insulated. So if you had ice in there, you're gonna end up with perspiration, condensation around the outside of it, and you'll end up with a little water thing around it. What is happening is the moisture is being taken out of the air. The heat is being taken from it, and it's making it into a liquid. Now, if you have that liquid and you keep taking heat out of it, it's going to become a solid. It'll be ice. Okay? If you add heat, it's gonna go from a solid to a liquid to a gas. If you take heat from it, it's gonna go from a gas to a liquid to a solid. Okay? It's the same thing. But remember that those molecules are moving. It's difficult to think about it, but yes, even in a solid, they are moving. Okay? They're vibrating, but they are still moving. Then we move on. What are mixtures and solutions? This is when I told you that in Miss Galley's class, you need to ask her if you can go get some
Universal solvent.
Universal solvent. Water is a universal solvent. Okay? Which means that it mixes with a lot of things. Not just one, but a lot of things. You have tea, you have coffee, you have soda, you have lemonade. Okay? All of these are no solutions. A mixture is if I had a fruit salad or even a salad. You can take the lettuce out. You can take, last night I made a salad with, my wife told me, she was at work and she said, can you cut up some cucumbers, some tomatoes, and some onions? So I cut up all three of them, mixed them together. Could I pull the onions out if I didn't like the onion?
Yes.
Yes, that is a mixture. A solution is something that gets dissolved in it. At the grocery store, you can go buy these powder mixes. There's Hi-C, which Crystal Light is another one. Hi-C, what people would do is they would pour that in, and then they'd put a little bit more sugar in it to make it sweet. But that sugar and the Hi-C, the Crystal Light, all of these are solutes being mixed with a solvent. Okay? Christian? A tea bag. You put it in hot water and you make tea, right? The water is the universal solvent. It's the solvent. The tea bag is the solute.
So it's the thing that gets mixed
That gets mixed in with the water. That gets mixed in with the universal solvent. If you keep remembering universal solvent and then take out universal, this is, on his, he's got H2. Where's the O? Come on. But if you remember that this, instead of universal, just remember that this is the solvent. But if you have to say universal solvent, Mr. Mink said we need to go get some universal solvent. Okay? This is the solvent. This is the water. Okay? The water is the solvent, and what you mix in it, that's the solute. Could be the tea, could be the coffee. It could be Gatorade, okay, because they have powder that they mix in. Hi-C, Crystal Light, all of these are solutes, okay? Yes?
Is a solvent only water?
No. It can be another liquid too.
Oh, so like a solvent.
The thing is with, the reason they call it the universal one is because it mixes with a lot of things. If you go look at the grocery store, look on the sides of bottles of different things, if you look on the side of the orange juice, okay, and find out, is it all orange juice in there? It's probably gonna say 10%, but it's also gonna have what in there?
Universal
Water.
solvent.
It's gonna have water in there, okay? And the reason why is because it's the popular one that mixes with everything. But it's not the only one that mixes. Yes?
So I get mixtures and solutions, but I don't get solvent and solute.
Solvent is the water,
Solvent.
okay, in this case. And if your mom made coffee this morning, she put coffee grounds in the coffee machine, okay? The coffee grounds are gonna go mix into the water, right?
And then it's a solute.
That's the solute, the coffee is, okay? If you mix, I know that they have these little packages that you can pour into your water bottles.
Oh,
It's a sugar, okay? Your water in there is the solvent, and that little package of flavoring that you're putting into the water, that's the solute.
Okay, so solvent is the water, but let's say you grab out
You put high C in it, you put Gatorade in it, you put
Gatorade
Crystal
powder in
Light.
it, and then it's a solute.
That,
And
no,
Gatorade powder is a solute.
yes,
but
the
water is
what you're mixing in the solvent is the solute, that's the solute, what you're mixing into it,
Okay, I understand.
okay?
Oh, yeah. I'm writing it
So-
down.
So the solvent dissolves the solute?
Yes,
How would you necessarily describe the solvent?
the solvent is what everything is dissolved into. Okay? This is what is dissolved, and this is what it is that you're dissolving it into. In this case, a lot of things get mixed into water. So water is the solvent,
So what everything is dissolved in?
what it is.
So the solute would dissolve into the solvent and become a solution?
Yes, exactly. Okay, what she just said is perfect. Say it again.
The solute would dissolve into the solvent and turn into the solution.
And turns into a solution. Okay?
Oh, okay, yeah.
So if you put,
So a solvent and a solution make a, or a solvent and a solute make a solution? Yeah.
they equal the solution. Now, the mixtures, I didn't touch on those too much, but we did, okay? We talked in here about trail mixes. We talked in here about at Easter, you have the jelly beans, and they have all the different colors, which are all the different flavors. Okay, Mr. Mink likes the green ones first, and then I go to the white, okay? Just so you know, I'm not a big licorice fan, so those go to the end. Oh, that's the way, that's my taste.
Disgusting.
They talked about fruit salads, okay? And even a salad that I made last night, okay? You can, as long as you can still take the things apart, you know, and separate everything out, it's just a mixture, okay?
Okay, so let's say you put salt and pepper on your omelet that you had this morning. That would be a solution, right? Because you can't take them apart.
No,
Okay.
you can. It's just they're smaller to where you can sit, it would take time, it's not like the
So,
bigger,
it's
it's not like the
considered a
bigger items, but they're not mixed, it didn't become a solution.
Okay, so it's considered a mixture.
Yeah, but if you put
Yeah.
salt in water,
It's a solution.
then you have a solution, you have salt water.
Because the salt is a solute.
Yes, the salt's the solute into the water,
Solution.
and you get a solution. Catching on now?
Yeah.
Okay, good.
Like, I put for mixture, well, I'm doing the definitions. So for mixture, I'm putting items you can put together and take apart again?
I'm gonna save you just a little time on that, because page 43 to 46 in your book is the definitions. Okay? And in your book, kids in the past have gone in their little page, it's a page, and what it has is you take the page and you flip it back and forth. On one side, it's gonna say salute. On the other side, and that just backed up to that part, is the definition for it. But there's all different ones, and you can go through and cut them out, okay? And use them like cards. The Quizlet, Ethan. The Quizlet has all the words in it also, okay? But on here, page 43, up at the top, it has molecule and atom. And if I flip it over, on the back, it has the definitions to them, okay? So don't worry about writing them down, but you can go to those pages and they're already there for you. Last part. This one was about matter. And with the matter, it's asking, how does matter change? It can change physically, which means if I take this paper that Ethan's sitting here doing and rip it up, he's gonna start crying over that, number one. But is it still paper? After I got done ripping it?
Yeah.
It's just smaller pieces, but it's still paper. It didn't change, okay? A chemical change, you're gonna end up with something new, okay? I sat and made you all so miserable yesterday because I was eating what for snack? A brownie.
I
A
don't
Mr.
like
Mink
brownies.
brownie.
I don't like that.
Now, the thing is, I put 2 eggs in that. I put a 1/4 cup of water, and then they had the brownie mix. From that brownie, can I go pull those eggs out? No, okay? The mix, it says brownie mix on it, but basically what it is flour and some sugar in there, things like that. It's not anything else. But once I take that, the 2 eggs, the water, mix them all together, it makes it into a goo. You pour that goo into the pan, and then you add heat to it, okay? And the heat is going to make something different. It's gonna make a brownie, okay? Now, I undercook it, so it's sort of still a little gooey, and it tastes great.
So I use my cookies.
You could do that with cookies also, okay? And the thing is you are actually making a new substance, because if you did it from scratch, you would have baking soda, you'd have flour, sugar, you'd probably put some drops of vanilla in there. There's all sorts of different ingredients, probably some eggs maybe, water, and you mix it all together, and then you put a clump on the cookie sheet. Then you put another clump. Usually you take a spoon to make it. Is that how you do them, Luke?
Yeah.
Okay, and then you put the clumps on there. You add the heat by putting it in the oven, and it makes something different. It doesn't make sugar, it doesn't make flour, it doesn't make eggs. It makes something completely different, okay? Now, they also talked about, we talked in here about bananas and tomatoes, okay? And if you were to take a banana and slice it up, did you make a chemical change? No. If you took the banana and you left it there and it rotted,
Yeah.
yes, it's becoming something different, and it's a chemical change, okay? If you were to add vinegar to the banana, chemical, because you go to, it's not gonna taste the same. It may look the same, but, well, it's gonna change, but it's still a chemical change.
Because the chemicals, like
Okay.
vinegar makes it like the taste change, and it's, yeah.
There's acids that are in that vinegar that are gonna change it altogether.
Anything make it a chemical change?
When you are making chemical change, you're gonna end up with something different,
Not
okay? Now, going back to the properties up here, in lesson 2. When you we had a discussion in here, there was a discussion about mixing some metal with sand, water, and shells. How would you separate them? You had some steel, some metal shavings, small pieces of metal. How would you separate all of that? Graham?
The magnet will take the metal and then.
First, you're gonna take a magnet to
Yeah.
get the metal.
And then the shells, put water in it, and the shells will float to the top and the sand will stay at the bottom.
Okay? Now you still have the sand in the water.
You use the thing that drops all the water and the sand will stay?
No, I know what it is. Drop on the
Strainer?
sand. Yeah, strainer.
Okay? That, or you could add heat to it,
Oh, yeah.
And then it will evaporate.
and the water will evaporate. Okay? Now, what you're doing is you're not doing it all at once. There's not one thing. You can't put the magnet and it's gonna separate everything out. But the magnet is one step. The magnet, you are going after the qualities of the metal. Okay? And you're pulling out that. And I told you that roofers do this. They have, it's like a lawnmower, but it's just a big, huge magnet. And they go walking around the yard after they take a roof off of a house because those roofing nails will fall on the ground. And all that they're doing is it's like they're mowing, but they're not mowing anything. There's no blades or anything. It's just picking up all the metal. Now, if there's other metal out there, yeah, it's gonna pick that up also. But it's gonna pick up all those roofing nails, so it's not dangerous to walk around anymore, okay? But you take the different qualities, the shells, you could basically pick those out if they're big enough. And then the sand and the water, if you add heat to it, or if you use a strainer, you can strain it out. We talked about in here, when you cook noodles,
Yeah.
you just have 2 ingredients. You got water and you got the noodles. You're boiling the water. Then once the water's boiling, you put the noodles in. You cook them for 8 to 12 minutes, whatever it says on the box, depending on the noodle. And when you're done, you have a strainer. I put the strainer in my sink, and I sit and take the whole pot and pour it into the strainer. What happens is the water goes right through the strainer, right through all the holes, goes down the sink. And what's left is only the noodles. I'll move the noodles around just a little bit to make sure that there's no water that's cupped in a noodle or whatever, and I get it all out, and that's how you separate them. Same thing with sand and water, you could do it that way. Luke?
A strainer, is that one of those like bowls with a bunch of holes in it?
Yes.
Yeah. You put pasta in it, and drink the water.
Last night, I made rice,
Oh, yeah.
and I have a hand one. that is small, and it has like a screen in it.
Oh,
And what, it has a screen.
Oh, like one of those ones that's like a screen, not like little.
Yeah, it's not the metal, solid metal where it has holes in it. This is, just has a screen in it, and it's smaller. And I was cooking a cup of rice. Well, the directions say you're supposed to wash the rice first. So I measured out a cup of rice, put it into there, put it under the sink, turned the water on, and it rinsed it off. Did rice go through? No. Did water go through?
Yes.
Yes, and it washed the rice off. Okay? Here I was getting hungry, I was trying to fix a nice meal for my wife, and I'm doing what? Science. You know? Gotta do science everywhere. Little do you know, a lot of the stuff that you are doing is science. If you just sit and think about it, it's science. Now, we have the iPads over here, and they have a charger that goes into it. That charger is bringing electricity from the cord into the iPad to charge the battery, right? And I'll take the last thing I do when I leave is I make sure they're all plugged in so they're charged, so that if somebody forgets to charge theirs at home, Harper, that when she comes in, she can borrow that and plug hers in over there. Now, when she goes to plug it in, is she getting shocked?
No.
Why?
Because of the rubber or like the plastic.
The plastic that's on the outside. The plastic does not conduct electricity. It's an insulator. We're not getting into insulators yet, but that's exactly what it's doing. Okay? Now, what do electricians do? What do they do with their tools? They fix the wires, but if I were an electrician and I took metal pliers and stuck it into where the electricity was, I'm gonna get shot because the electricity goes through metal. What do they have special with theirs?
Did they put something like on the grip so that it's like plastic or rubber?
Yes, they put rubber onto the grips of it to where the handles are, okay? So that it doesn't shock them, okay? Here I am cooking again, I've got a wooden handle on my pot. Why? It's an insulator. It's not, just like electricity goes through metal, if I had a metal handle, I would also have heat going through it also, okay? But that wooden handle, that plastic handle that you have on your pots and pans, it's there for a reason, okay? Sure, they make it look decorative and everything else, but the main purpose is that so it doesn't conduct the heat through it. Now, there are certain pans that we have at our house, they're cast iron, they're heavy, they're big, they're black, and they're cast iron, but that's the way that they're built, that's the way they are. And you have to put on a hot mitt or a glove, or take your dish towel, wrap it around it, so that the heat doesn't go through to your hands, okay? Now, if you were paying attention, if you took notes, okay, you should do pretty good.
Very beautiful.
Now, one other thing. This pencil, what is this at the end? Lead. What is it also called? Nope, close. You're close. Graphite?
Yes.
Okay, graphite. Graphite is carbon, okay? And the way that those graphite carbon are laid out, they're laid flat, okay? And that's what makes it, you know, into the lead that you can write with, okay? What happens if they changed them and made them into a pyramid?
Diamond.
It'd be a diamond. It's still, this is the same in his pencil that what's in a diamond. It's the same, it's just put together differently, okay? And you need to remember that. Hint, hint, hint. What do we need to remember? What did they just talk about, Christian? Diamonds and graphite. What's the difference between them?
The way it's made.
The way that they're put together. The graphite is in a sheet, it's flat. The diamond, the molecules are put how? No, not a diamond shape, a pyramid shape. Pyramid shape. It's made out of carbon, which is the same as your pencil lead, yes. Huh? Yes.
Graphite is made out of sheet.
A what?
A sheet.
The graphite is laid like a sheet.
Okay, I'm reading it.
The diamond is laid like a pyramid. All right?